Welcome back, folks. Today's lesson is going to be about something we call natural logarithms. Let's start off with this problem here. We're investing $1,000 into an account making 8% compounding continuously. So compounding continuously means we're going to need to use A is equal to PERT, or PE to the RT. We're trying to figure out how long before it's $3,000. So $3,000 is the amount we want. We started off with, or our principal was $1,000, and we have e to the, our rate is 0.08 t. Now how do we find out this time that we need? Well, for starters, we need to get this t out, so we could divide by 1,000. We'd get 3 is equal to e to the 0.08 t, but now we need some sort of logarithm base e. And this is where the natural logarithm comes in. We have the natural logarithm, and we call it ln. For some reason, it's likely because it came from something like French. It's log natural or something of that sort. But we have the function y is equal to ln of x, and ln of x, or natural log of x, and e to the x are inverses. Ln of x is just a fancy way of saying log base e of x. So anytime you see ln of x, that's just meaning we're doing log base e of x. And because it's just log base e of x, all of our rules for expanding and combining the natural logarithms are the same as for any logarithm. So let's take a look at an example. We have 2 ln of 15 minus ln of 75. If this were a normal logarithm, we'd take the 2, we'd move it in as a power of 15, and that's exactly what we're going to do here. This is going to be ln, or natural log, of 15 squared minus natural log of 75. Now, as these are subtracted, that means we're going to divide them inside a single natural log. So we have ln of 15 squared over 75. Our last step is to make sure that 15 squared over 75 can't be reduced. So we're going to throw that into our calculators. When we do, we put in 15 squared divided by 75. That'll give us 3. So our answer is this is the natural log of 3. Okay, what about problem 2? How would we reduce 3 ln of x minus 2 ln of 2x into a single equation? For this one, we start off with the coefficients again. So we get the natural log of x cubed minus the natural log of, and this is important, everything inside the original natural log is squared. So it's 2x quantity squared. Now because these are subtracted, that means we're going to divide, so we'll have the natural log of x cubed divided by 2 squared is 4, and x squared is x squared. Finally, all we need to do to reduce this is we have x cubed on the top and x squared on the bottom. Let's cancel those out, and we'll have the natural log of x over 4. And one last one here, we have 3 ln of x plus 2 natural log of y plus natural log of 5. How do we combine those? Again, we're going to start off with our coefficients, so this will become the natural log of x cubed plus the natural log of y squared plus the natural log of 5. And then we just combine these all together. Right? These are all addition, so we just multiply them all through. This becomes ln of 5x cubed y squared. Now, solving natural logarithms is the same as solving any other logarithm, except for we have a base of e. So if we have ln of, and this is quantity, x minus 3 squared is equal to 4. That means that we are going to have a log base e of this value. We're going to make that e raised to the 4th power on the other side. So this becomes x minus 3 squared is equal to e to the 4th. We're going to take the square root, so this will become x minus 3. And because it's us taking the square root, we need to have a plus or minus. So this is plus or minus the square root of e to the fourth. And the square root of e to the fourth is going to be e squared. So our value here is going to be plus or minus e squared. Our answer is x is equal to 3 plus or minus e squared, which we're also going to throw into our calculators to get a decimal approximation. What's 3 plus e squared? We put that in. What is 3 plus e squared? That is roughly 10.389. And what is 3 minus e squared? Well, 3 minus e squared is going to be roughly minus e squared is roughly negative 4.389. And the important thing here, just like with any other logarithm, we have to check for extraneous solutions. The best way to do this is going to be taking these decimal approximations and substituting them in for x, seeing if we get values close to 4. So we'll take 10.389 and substitute it in for x. You'll put in ln of parentheses, just like we have here, parentheses, a second set of parentheses, x minus 3 squared, and see what that gets you. And when you put in ln of 10.389 minus 3 squared, you get pretty much 4. Check it with negative 4.389 as well, ln, or natural log of negative 4.389. That gives us also 4. So neither of these are extraneous. Let's have you try this next one. What is x going to be for ln of 3x plus 5 squared is equal to 4? We're going to follow the same steps as we did before. We have a natural log here, so that's a log base e. We're going to bring the base e over to the other side. This is 3x plus 5 squared is equal to e to the fourth, or that means 3x plus 5, when we take the square root, will be equal to plus or minus e squared. Don't forget your plus or minuses. Then we solve, we subtract 5, we divide by 3. We get x is equal to negative 5 plus or minus x squared over 3. We'll put these into our calculators to do decimal approximations, but remember, you're going to want parentheses around your first, or your top terms here. That makes sure that we add all of this together before dividing it by 3. So throw it into your calculator like this. What's negative 5 plus e squared over 3? That's going to give us x is approximately 0.796. So that's going to give us x is approximately 0.796. And our second term, negative 5 minus e squared over 3, is going to give us a value that is roughly negative 4.13. Again, to test these are extraneous solutions, just substitute them back in. What is ln of? Remember, we have our brackets around here. 3 times 0.79 plus 5 squared. Put that in. Should be approximately 4. And what about negative 4.13 times 3 plus 5 squared? That should be approximately 4 again, so we're good to go. Okay, one last one. What is ln of 2x plus ln of 3 is equal to 2? What's x? For this one, we have to combine these two. So it'll become ln of 2x times 3, or ln of 6x is equal to 2. So we have a natural log, or log base e. That means that 6x will be equal to e squared. We take the e value and move it over to the other side, where x is going to be equal to e squared over 6. Substitute that into your calculator. You should get x is approximately 1.232. Then all we need to do is substitute that back in. What is ln of 6 times, or natural log of 6 times 1.232? Let's figure that out. Natural log of 6 times 1.232 is going to be nearly exactly 2. So we're good to go. Right. This leads us on to solving exponential equations. Same as we did before, except for this time our base is going to be e instead of a normal number. Our first step is still going to be try to get this function, this power, by itself. So we're going to subtract 2. We'll get 4e to the 2x is equal to 14. And then we're going to divide by 4. When we divide by 4, we'll get e to the 2x is equal to 3.5. So two different ways of doing this. The first method is going to be get rid of the e to the x by taking the ln. When we do that, we move the e over to the other side. We get 2x is equal to ln of 3.5. Right, we're taking the log base e of the other side to get our 2x down. That's going to give us ln of 3.5, or x is going to be equal to the natural log of 3.5 over 2. Put that into your calculator, and that should come out to be approximately 0.626. Now what's method 2? Method 2 is we're going to take the natural log of both sides. And you can do whichever one of these seems easier for you, whatever feels right. When we do, we'll have the natural log of e to the 2x is equal to the natural log of 3.5. Now we have a power of 2x, so we can pull that out. This is 2x times the natural log of e is equal to the natural log of 3.5. And what's the natural log of e? Remember, this is log base e of e. So this is asking us e raised to what power gives us e? That's just 1. So this simplifies down to 2x is equal to the natural log of 3.5, which is just what we got this other way, and we can see that that'll get us to the same answer. All right, let's have you all try a couple. What is the value of x going to be in e to the x minus 2 is equal to 12? To start off, we have a base e. Using either method, we're going to take the natural log. When we do, we have a base of e, so we'll get rid of that. We have x minus 2 is equal to, we move the e over to the other side, it'll become the natural log of 12, or the log base e of 12. That tells us that our value is going to be x is equal to 2 plus the natural log of 12. Now we can't combine these because 2 doesn't have a natural log or a log of any sorts on it. Instead, we're just going to get a decimal approximation by saying that this is 2 plus natural log of 12 in our calculators, which tells us x is going to be approximately 4.485, excuse me. One more of these. What is e to the 3x plus 5 is equal to 15? What is x? So we're going to start by subtracting 5. That'll get us e to the 3x is equal to 10. And now we have our exponent in our power, meaning that we're going to have to get rid of this power. We'll take the log base e, or the natural log. So we'll have 3x is equal to the natural log, or log base e, of 10. Then all we do is we divide by x. We get x is equal to the natural log of 10 over 3. Again, we can put that into our calculators for a decimal approximation. So x is approximately equal to the natural log of 10 divided by 3. Or our value is going to be roughly 0.768. Okay. Where will this show up? Let's do a couple of real-world problems. Starting off, we have $2,500 in an account that makes 12% compounding continuously. We're trying to figure out how long it'll take to have a value of $4,200 or $4,200. Remember, compounding continuously means we're using A is equal to PE to the RT. Try to figure out what the equation would be to start. To start off, we're trying to get $4,200 or $4,200 in an account. We started off with $2,500. We'll have e to the 0.12, our rate is 12%, t. Okay. And try to solve from here. Remember, you're going to have to get the e by itself before solving. How long will it be? We're going to start off by dividing 4,200 by 2,500. We'll get e to the 0.12t is equal to 4,200 divided by 2,500, 1.68. Now we have an e on the one side, so we need to get it over to the other side. We're going to take the natural log. We end up with 0.12t is equal to the natural log of 1.68, or t is going to be the natural log of 1.68 over 0.12. All we need to do is throw that into our calculator to figure out roughly how long it's going to take. So we take t, and that's going to be equal to ln of 1.68 divided by 0.12. I'll tell you, it'll be approximately 4.3 years before you make that amount of money. We have one more here, which you can do. Make sure you're comfortable with it. However, that's all we're going to do for today's lesson. Natural logs is very much the same as solving with logarithms, except for now we're dealing with log base e.